Good afternoon. My name is Kevin Johnson, and I'm the Director of Marketing at Allentown. I'd like to welcome you all to Let Us Show You Why, Allentown's web seminar about wireless IVC rack monitoring with WICOM, our new wireless monitoring system. Before we begin, I'd like to briefly discuss the format of our presentation. First, there'll be a short introduction and overview of IVC rack monitoring in general, including the challenges inherent within manual and hardwired systems. Following that, there'll be a comprehensive presentation of the WICOM system, the majority of which will be a live demonstration of the software application. Finally, we will open up the phone lines for questions and answers, where we will answer any questions you may have. Including the questions and answers, the seminar should last between 30 and 45 minutes. There are several participants in today's seminar, all connected through the conference call. So for the presentation portion of the seminar, you'll all be on mute, as Frank just mentioned. Once the presentation portion is complete, we'll unmute the phones, and each and any of you can pose your questions. After today's webinar is complete, a full replay is going to be available on our website. I'm sure you'll find today's event to be informative and useful, and thank you for attending. I'd like to introduce today's participants. In addition to myself, you'll be hearing from Frank Bartell, Allentown Software Marketing Specialist, and Steve Miller, Head of Allentown IT and Product Development. So without further ado, I'd like to introduce Frank Bartell, who will begin with an introduction and overview of the IVC rack monitoring.
Thank you, Kevin. Good afternoon, everyone. Thank you all for attending. As Kevin said, my name is Frank Bartell, and I'll be presenting the first portion of our seminar, which will be a brief overview of rack monitoring in general, followed by a short introduction to our WICOM demo. My intention is to take a sort of soup-to-nuts view of IVC rack monitoring, but from a high level, hopefully covering the important points, including some of those things that most of you may already know. But in the interest of completeness, and for the sake of those in attendance who may not know some of this stuff, I'd just like to start at the beginning. So, to begin with, let me start with a question. Just what is IVC rack monitoring? Quite simply, it's the consistent, periodic sampling of research animal housing parameters or conditions. Those conditions may include temperature, humidity, air change or ACH, filter status, IVC pressure, and blower status, just to name a few. Now, why do we do this? For many reasons, certainly, but for the most part, to control, maintain, and hopefully improve conditions within your vivarium. The idea being, if you know what's occurring at a fundamental level now, you can attain a greater control over what occurs going forward. I'll give you an example. There was an incident in July of 2006 at a major Midwestern university involving a building management system where, following a power outage, the BMS automatically turned on the heat within the facility. Only problem with that was it was during the summer. As a result, due to overheating, nearly 700 laboratory mice and rats, as well as hundreds of hours worth of scientific research, were lost. Had that facility employed a successful and robust monitoring system, an alarm could have been triggered to alert researchers that conditions within the vivarium were reaching critical levels. Another use for the information gleaned from monitoring is to aid in equipment maintenance. Obviously, if you know a blower or filter is about to fail, or know precisely when this equipment has failed, preemptive or at the very least swifter action can be taken to prevent further mishaps. Still, another benefit of this type of documented and verifiable information is to aid in any sort of accreditation, grant application, or regulatory compliance process. So to sum up, superior data equals superior science, and of course that's what we're all after in the end. Now, given that we accept monitoring as a worthwhile endeavor, we should discuss the various types of traditional monitoring that can be performed. These are manual and hardwired. Manual monitoring is, of course, the periodic sampling of conditions by a human being, ranging wildly in scope and complexity from simple room temperature readings to more sophisticated sampling. This is traditionally performed by an attendant who enters the vivarium any number of times during a given day and takes environmental readings, documenting the results by hand. Hardwired monitoring uses a network of oftentimes complex and cumbersome wiring attached directly to both the racks being monitored and the station receiving the data to sample these very same conditions. Both of these monitoring methods bring with them a variety of issues and challenges, each impacting the facility's ability to function and the quality of the data being collected. First of all, both of these methods can be labor-intensive. This is easily understood when discussing the manual method, but even hardwiring can require a great deal of time and effort in both implementation and maintenance. Both of these methods can also be quite costly. The expense to implement and maintain a hardwired system can impact the bottom line in a meaningful way, as can the expense associated with an employee performing these functions by hand. Both manual and hardwired monitoring can also be consistently intrusive to the facility. And in an industry where the cleanliness, integrity, and biosecurity of the vivarium is of critical importance, limiting the degree of entry into the room can only help to support this effort. The next issue has everything to do with data retention and reliability. Recording data by hand onto paper, as is done in conjunction with traditional methodologies, is characteristically perilous to the collected information, subject to destruction, loss, and misinterpretation. Lastly, and applicable only to hardwiring, is the issue of BMS dependence. The building management system of any given facility will have greater or lesser degrees of functionality depending on the BMS, and therefore the hardwired system employed, which is fundamentally dependent upon the BMS, will share these limitations, regardless of any inherent robustness. Having heard of the overheating situation at the Midwestern facility, I think we can all appreciate the limitations of certain building management systems. So, what's the alternative to manual or hard wiring? Monitoring with Wycom. First off, let's talk about what Wycom is. In short, Wycom is Allentown's real-time wireless IVC rack monitoring system. It provides users with the ability to wirelessly sample IVC rack conditions in real time, which means that at the precise moment you need the data is there for you. Wycom allows users to monitor the following conditions: temperature, humidity, air changes or ACH, filter status, IVC pressure, blower status, and alarm status. Basically, the full range of parameters and conditions necessary for the successful maintenance and success of your facility. And it does it wirelessly, with all the convenience and security of tried and true Bluetooth technology. In addition to the collection of this data, Wycom provides a robust assortment of reporting and notification tools necessary for the strategic use and implementation of this critical information. In regard to reports and reporting, Wycom uses easily recognizable formats and allows for any number of preset or customized reports to be generated from the system's central data repository. Later on in this seminar, we'll show you examples of some of these reports. In addition to this, Wycom provides alarm notifications for, among others, the following conditions: blower failure, HEPA filter loading, and temperature and humidity limits. These alarm notifications can be delivered in a variety of secure, convenient formats, including email, text, and phone message. No longer is it necessary to be physically on site to be certain that your facility is functioning as it should. Now, with Wycom, practically no matter where you are, the system can find you. Of course, Wycom is largely customizable, and users can determine and set their own parameters regarding unacceptable breaches, as well as the manner and frequency with which they are notified about them. Finally, Wycom can provide users with an overall reduction in the time, expense, and contamination dangers that are inherent in the application of manual or hardwired IVC rack monitoring systems. So to sum up, I think we can all agree that monitoring is a good idea, with the data collected from doing it properly being something that can only benefit the success of your facility and the science you carry out there. The question is, how will you perform that monitoring? To help you make that decision, I want to introduce Steve Miller, Allentown's Head of IT and Product Development, who will continue our presentation with a live demo of the Wycom software.
Good afternoon. To get started, there's some hardware that's involved in order to do wireless monitoring. First off, you have to have wireless capable blowers. From Allentown, we supply the Smart Supply Pack, an SP4100, a Smart Exhaust Pack, an SC6100, or a biocontainment unit, which is our BC8011. All are capable of being outfitted with Bluetooth technology. The blower upgrade options that are required are exactly that, which is the Bluetooth module, which also provides you with the antenna, which is being displayed in the lower left-hand corner of the blower here, and also a temperature humidity option so you can monitor the environmental conditions that are entering and exiting the rack. Both of these are included in our XJ product offering. Why did we choose Bluetooth? First off, Bluetooth has excellent RF noise immunity. It has that immunity due to the frequency hopping that it does on the 79 channels that it can access. It also is capable of coexisting with other medical devices. This could be important if your facility currently uses things such as medical microwaves and telemetry. It's also a low-power transmitter, and it is also FDA approved. For security, Bluetooth offers a PIN code which provides 56-bit encryption. It meets international EMC standards as well. In the holding room, all that's required to monitor the racks wirelessly is the Bluetooth access point as displayed on your screen currently. When that is mounted on the wall inside your room, it's held up high with its outlet and its data link so that it can then transmit that data back to a main station. The main monitoring station includes a PC, as shown, a laser color printer for report printing, a battery backup if your facility currently doesn't have the ability for power backup, and a switch to offer connection between multiple access points. The overall hardware architecture, which is shown in this screen right now, shows where everything falls into place when it's hooked up properly. The upper left-hand corner has your PC, which is then hooked in through a switch, which then is wired out to the access point. All your data then is collected wirelessly to the racks for ease of use inside the holding room. Also, there's your laser printer so that you can get your prints out in color, and then this line right here shows the connection to the internet if you'd like to be able to do email alerts, text messaging, or customer help. Customer responsibility is also required in terms of the wiring that has to happen between the holding rooms and the monitoring station. If access is provided for Allentown to utilize a current local area network, a LAN, then that wiring is not required as long as all the proper permissions are also provided. We also need an electrical power outlet for Bluetooth access point, a location for all the hardware that we just mentioned, and as we also mentioned, the high-speed internet access for the alarming and support features. Other wireless considerations in the facility will have to be taken into account depending upon your certain circumstances. At this point, we're going to do a small software demo for you. What you're looking at right now is the main interface screen that the YCOM system provides. I'm going to start in the left-hand top corner of your screen, and I'm going to work around the display counterclockwise. First up, we have the facility status indicator. It's a green ball when all the systems are working properly. When something is not working properly, it turns red and it flashes. This is so that it's easy to see as someone is passing by or walking by the station to understand or easily see that there's something that's not right. Just below that, in the rack information screen, we're displaying the actual information that's being taken from the specific rack at that particular point in time. The first line is the temperature, which shows the supply or the air entering into the rack, and the second column displays the air exiting the rack. The second row down displays the relative humidity entering the rack, and on the right-hand column, the relative humidity exiting the rack. And the last line shows you the air changes per hour that the current blower is set to, and the right-hand column shows you the polarity of the particular cage and rack that's being monitored, whether it be positive or negative with respect to the room. Just below that, we have a filter indicator. This indicator is much like that, bars on a cell phone, whereas when all the indicators are full, it tells you that your HEPA filter is completely capable and does not have much use. If the HEPA filter starts to deplete, these lines move down progressively. Just below that is our alarm summary table. What you see right there is 2 alarms that have already occurred. You may be asking yourself right now, well, I have 2 alarms, but yet my indicator up top is green. If an alarm actually occurs and then is cleared, it still stays in the alarm summary table until a proper person acknowledges the alarm. And I can show you that right now. I'm going to acknowledge the alarm and it'll clear. There's also another alarm here where we can actually take a look at, instead of clearing it, we're going to view the detail. What this shows you is that in your particular facility at Allentown, in the west wing of the building, on the second floor in the IT office, we have a rack, BCU XXX, which has a blower mounted on top that has a filter issue. We can clear that as well. Moving over here to the right-hand side of your screen is the rack summary table. This displays all the racks that are currently being monitored. Right now we only have 5 racks that are being monitored, if you had more racks in your facility, this screen would be completely filled up and would have a scroll bar that would allow you to scroll down and visually see what's happening with some of those other racks. If you take a look at this bottom level right here, this is a BCU unit, which is a negative only type unit, and you can see that it's missing the supply data, which is actually correct. You have the blue markers that are working down and shows you specifically which rack is the data is actually being taken from. The top headers show you the airflow, both entering the rack, the pressure as far as your cage polarity, temperature entering and exiting, humidity entering and exiting, and the filter life expressed in terms of percentage of available HEPA filter that's remaining. As far as the setup of the system, if we go to the tools and user information, we can actually go ahead and add in a new person here, just for demonstration purposes. We're going to add in Vince Pombo, and we're going to put his username in. And we're going to make Vince an alarm responder. What the alarm responder means is that a notification email will be sent out to him upon an alarm condition being realized. The access level we're going to provide to him is going to be an administrator, and he has the option of receiving an email, a text message, or a voice message. For this purpose, we're going to have it just so that he receives an email. And we're going to save this information. Some other parameters that you may want to set up ahead of time would be underneath our alarm screen. The first one up is alarms and alerts. This shows all the parameters that are currently being monitored and how you would like to be notified or indicated as to what's actually occurring. First-hand column is notify, which means something will be sent externally for you to review or to notify you that there's a condition that's occurred. In the middle column, it means that it will only happen on the screen and you will not be notified externally. And you may want to ignore a condition at the right-hand side here because you may only want to be able to plot data from, say, temperature, humidity, but not necessarily be notified if there's an alarm condition. So for this purpose, I'm just going to put screen only with the temperature and humidity. And I'm going to leave the HEPA filter, blower, and the power as a notify. I'm going to save that. The next setting underneath the alarms is notification and priority scheduling. This is split up into two columns here. We have weekdays, and we have notification priority, and we have weekends with notification priority. Whether or not the system sends out to the weekday or the weekend person is signified down by the calendar work week. When there's a checkbox next to a date or a day here, it'll send to the weekdays. If it's not checked, it'll send it to the weekend. And there's also a work time here set so that we know if we're also sending to a weekday or a weekend. Just for purposes here, we added Vince Pombo in, and we're going to go ahead and we're going to put him as the first notification on a weekday. The next item up, underneath the alarms condition, is the actual settings for the environmental conditions. We may want to change when these trip points are set. If you take a look, we have a lower critical limit, then we have a minimum limit, a max limit, and an upper critical limit for temperature, humidity, and air changes per hour. For ease of use, we've loaded into the system reference values. For the U.S., we have the guide. For the U.K., we have the Home Office guidelines. And for the European Union, we have the European Council. For this particular demo, we're going to set up the U.S. guidelines so that the temperature, humidity follow what's stated inside that book. And we're going to save that. Okay. Now what I want to show you is we've been taking data as the system has been running, and I'm going to show you how we're going to get a graph out of the system. We have three charts that we can plot on the same graph. We have one for temperature, humidity, and air changes per hour. On the right-hand side, you can select by either room. We can change it to a rack if you want to just plot a rack data, or we can change it to an actual blower data. We're going to go back to room, and we're going to select the IT office where these particular blowers are located, taking our data, and we're going to have them plot out all three graphs. Before we plot the graphs, though, we're going to want to go to the settings menu, which also has that familiar looking screen for the temperature, humidity, and ACH. But this is going to print a band on your graph which is out of limits so that it's going to be easily identifiable as to those conditions that are outside of your normal range. We're going to use our reference values of the guide again, and we're going to save that. And then we're going to display it. And this is going to generate the graph for you real time here. As you can see with the yellow banding, our temperature is within spec all the way up until this last data point on the right-hand side. And the humidity is also out of spec down at the lower right-hand side. And the ACH is also a different parameter than what we've predefined as well. With this, you can leave it just on your system and view it on the screen, or you have the option of actually saving that data to a JPEG file so that you can import it into a document or a report that you may be writing. So we're going to do test demo 2, and we're going to save that JPEG file. Okay. Some of the other items that we have available to us, we may have some updates that we need to have the system update itself. So if we go to the updates bar, it'll automatically go and it'll check for some updates. None there. Or we may want to archive some data, or we may want to archive or back up the system. We have the option of doing that to a CD-ROM, as you can see here, or we can archive a specific time period that may be important to a certain investigator, and he may want to access that, he or she, at a later date on an Access database. Okay, what I'm going to do right now, I'm going to demo a condition, a fail condition, and I'm going to show you how the screen changes from a green to a red ball and how the alarm shows up. You can just see the left-hand side, the alarm showed up. On the right-hand side, you saw some scanning, which is sending a text and an email message out. And at the top, you can see the red ball has now changed from a green to a red indicator, showing you that you have a failed condition. Now, this condition will clear itself on the next go-around, since it was a test alarm. But that alarm summary table will still have the VCU filter alarm displayed at the bottom left-hand side. At the same time, when you saw that come across on your screen at the lower right with all those scannings, I now have received a text message on my phone indicating that there is a filter issue with the PCU unit. We also have the ability, I just unchecked a box at the top left-hand corner for a specific rack. We have the ability to clear a rack or prevent it from being monitored in case we have blower maintenance or rack maintenance that has to occur. The next time the system runs around and does a scan, it'll update that information and it'll skip it on the next scan period. You can see we cleared the alarm, and now we're going to skip over this next rack because we have it out for service and maintenance. So just skip right over it. That way, if there's an alarm condition on those racks, it doesn't get displayed or notified. I'm going to click it back, and in the next scan cycle, it'll go ahead and start taking data from that specific rack. At this point, I'm going to hand the screen back over to Frank, who will then go ahead and field some question and answers.
Thank you, Steve. Okay, we're going to open up the phone lines in just a moment, and then you'll be free to ask whatever questions you may have. There'll be no official format for the Q&A. However, I would ask that you identify yourself before asking your questions if you feel comfortable doing so. Certainly this is not required. And I would ask that we all endeavor not to speak over one another. So,
the conference has been unmuted.
The lines are now open. Please feel free to ask any questions you may have.
How you doing?
Good.
With the Wycom system, I know how it works with the individual blowers. How does it pick up the separate racks when you've got interstitial blowers?
Currently, the system doesn't tie into interstitial blowers, though it's something that we're looking at in the future.
Is that going to be feasible within the sort of next 12 months or so?
I'm going to say it's amongst possibilities, yes, Pete.
Okay, cheers. That was my question. Thank you.
Do we have any other questions?
No, that's it. Thank you.
Okay, anyone else?
We have older blowers. Would the blowers have to be modified, or is there equipment that could be added on to them?
Well, we would have to understand how old the blowers are, and the reason why I say that is because approximately in the March-April timeframe of 2006, any blower, smart pack blower that left this facility was capable of being upgraded with the Bluetooth and the temperature humidity chip. If it was manufactured prior to that date code, it would mean that your control board would have to be updated in order to accept the modules that I just talked about.
Are we also talking about prices with this, or is this just a number of blowers?
Well, that's going to be dependent upon the size of the project, to be honest with you, and we would really prefer that you spoke to your local representative and they can work up a quote for you.
Okay.
It is highly dependent upon the layout of your facility, the number of pieces of equipment you have, and all of that.
And then again, too, I'm assuming this is only can be done to Allentown caging equipment.
That's correct.
Okay.
Anyone else?
Yes. Well, Bluetooth would have to be also put up in every room to where these racks are located, correct?
That's correct. The Bluetooth access point is required. Currently, we specify one per room without knowing anybody's specific facility as far as what the walls are made of, whether it has metal, whether it be sheetrock. So we specify one per room. If we get to a facility and we find out that we're getting good signal strength through certain walls, there's the possibility that we could reduce the number of access points at that point in time.
Is there a limit to the number in one room area?
No, there is not. We monitor one rack at a time, which means that we're making one Bluetooth connection at a time, which means that we can have theoretically, an infinite number of modal points that we actually monitor.
Okay, thank you.
Is there anything being done with, let's say, the cage level monitoring temperature and humidity, like a sentinel cage on a rack, or for data gathering?
We currently don't have anything like that, Rick, but we're investigating possibly having something like that within the next year or so.
Okay, thanks.
Are there any other questions?
If you have wireless already in your facility, could it limit some of the Bluetooth connections or anything?
Currently, the blowers are set up to only work with Bluetooth versus Wi-Fi. I'm assuming that if you're saying you have wireless in your facility, that it's probably Wi-Fi?
Yes.
Okay. It's currently not set up to be able to handle that. We could talk to you offline on a one-on-one basis because there is a module that we could substitute out, potentially for Wi-Fi. We haven't done that in the past just because of interference issues that Wi-Fi offers versus Bluetooth. Bluetooth tends to hop frequencies versus Wi-Fi tends to stay constant once you have a connection.
Thanks.
Is there a next question?
Are you thinking about having at least a room monitoring point for temperature and humidity as kind of a correlation between the racks and the room itself?
Well, on the supply side blower, we're measuring the temperature and humidity of the air going into the rack, and it's pulling the air directly from the room. So the data you get from that point is going to be indicative of what you're seeing in the room.
Good. That's a good point, Jim. Thanks.
You're welcome. Are there any more questions? Okay, so that will conclude our afternoon session. Should you require any additional information or have any other questions, you can contact your sales representative or use any of the information that you see on the screen in front of you.
So we'd like to thank you all for joining us here today. As we mentioned at the beginning of the presentation, there will be a recording of the session available on our website. And as Frank just said, please contact the local representatives for further questions and price quotes. And you may contact any of our presenters today by email. And at the end of the presentation, when you close out, there will be a follow-up form that appears on your screen. We would appreciate it if you could use that to give us some feedback on today's presentation. We hope that you found it informative and thought-provoking. And again, thank you and goodbye.